Hey everyone! Okay, let's dive right into a seriously frustrating mystery that pretty much every IT professional has faced at some point. And more importantly, let's figure out how we can finally solve it. In this explainer, we're basically putting on our network detective hats. We're going to explore how to move way past the limitations of traditional troubleshooting tools and step into the world of true, full-stack network observability using RPM.
Here's our case file for today. First, we'll examine the ping blind spot. Then we'll unmask RPM, crack delay, and jitter. Segment the fault, quickly compare RPM to 2WAMP, and finally, look at modern network observability. Let's get to it.
You know the drill. The network is slow, my VoIP call is super choppy, or this video conference just keeps stuttering, right? We have all heard these complaints. These are the frantic tickets that set off alarms in our heads and launch us into immediate detective mode. We sit down at our terminals, absolutely ready to find the broken link. But then, we run into the classic IT paradox. You pull up your dashboards and nothing. You check the interface traffic, it's fine. CPU and memory, totally normal. Routing tables look perfectly stable, and there is literally not a single red alarm on your screen. The network looks completely green, yet the users are clearly suffering. So where on earth is the problem actually hiding?
That brings us to Section 1, the ping blind spot, and why our absolute oldest tool often falls short. Just look at this contrast. Your basic ping command might be showing a simple, healthy 20 millisecond delay with 0% packet loss. It looks totally pristine. But then, the actual user experience for a voice over IP call is suffering a crippling 200 millisecond delay and 80 milliseconds of jitter. The voice traffic is essentially being shredded to pieces. Why the huge difference? Well, because a standard ping is just a single snapshot in time. It's not a reflection of a continuous real-time application flow.
Which leads us to Section 2. Unmasking RPM, active, continuous measurement.
So what is RPM? It stands for Real-Time Performance Monitoring. And the key thing here is that it isn't just a passive observer sitting around waiting for a threshold alarm to go off. It's a built-in, active measurement mechanism right inside Junos. It's continuously sending out specialized probe packets to meticulously record round-trip time, one-way delay, jitter, and packet loss.
So how does this actually operate out in the wild? Well, instead of just sending one quick echo request, RPM acts as a relentless, active monitoring system. It uses continuous ICMP or UDP probes. For example, you might have it originate from a core device like an MX960 and continuously target a provider edge router down the line. And because it literally never stops measuring, it captures those tiny micro fluctuations in delay, jitter, and loss that a basic ping completely ignores.
Moving into Section 3, cracking delay and jitter. Because guys, it really is all about the fluctuations.
If we look at a batch of 5 consecutive probes, the latency might hover right around 20 milliseconds. That gives us a really smooth, healthy average, right? But the jitter, which is the variation in that delay, tells a completely different story. Probe 2 spikes to 40 milliseconds, probe 4 hits 50, then it instantly drops back to 15. Your average is 28 milliseconds, but the flow itself is highly volatile. And this wild microscopic fluctuation, that's exactly what causes your voice calls to sound robotic and your video to freeze up, even when average latency seems perfectly fine.
And then we have another silent killer, micro packet loss. Imagine we blast 1,000 probes over the network. We get 990 back perfectly fine. That's a 99% success rate, with only 1%, just 10 tiny packets lost. To a basic ping test, a 1% loss seems basically negligible. But for real-time voice and video applications, 1% packet loss is an absolute disaster. It causes major audio dropouts and crazy syncing issues.
Section 4, segmenting the fault, or how we hunt down the exact bottleneck.
This is where we build our investigation strategy. Say an ERP system is slow. If we just do a standard end-to-end ping from the user straight to the data center, we might see a total delay of 193 milliseconds. Cool, we know it's slow, but we have no idea where it's slow. RPM allows us to do segment monitoring. We literally break the path down. PE1 to PE2, 5 milliseconds, healthy. PE2 to the core router, 8 milliseconds, healthy. But from the core to the data center, bam! 180 milliseconds. By slicing the network into segments, we instantly isolate the exact fault domain.
Let's look at a real-world case study of this in action. A client reported dropping VoIP quality. Network engineers checked everything, interfaces, CPU, memory, and it all looked totally normal. But by deploying RPM segment by segment, they isolated the fault specifically to the link between the core router and the session border controller. RPM caught a 20 millisecond latency and, crucially, a 5% packet loss on just that specific hop. Because they knew exactly where to look, they dug deeper and discovered output queue drops on a massive 100G interface. The final verdict? Hidden link congestion that standard polling was completely blind to.
All right, Section 5, RPM versus TWAMP. Choosing the right investigative tool. So RPM is simple to deploy, it's built right into Junos, and relies on standard ICMP or UDP. Honestly, it's the absolute perfect lightweight tool for smaller networks or environments that are primarily Juniper. On the flip side, we have TWAMP, the two-way active measurement protocol. This is an open standard designed to measure metrics across different vendors. If you're running a massive, multi-vendor telecom network with Juniper, Cisco, Nokia, and Huawei gear all talking to each other, TWAMP is the heavy-duty standard you're going to need. But for native, rapid deployment within a Juniper ecosystem, RPM is your go-to every time.
And finally, Section 6, Modern Network Observability, putting it all together. This sequence right here shows the true power of modern network architectures. RPM is the engine. It generates the active probe data at the hardware level. But we don't just leave it sitting on the router. We use JTI telemetry to continuously stream that data off the box. A collector, like Telegraph, grabs it, pushes it into a time series database like InfluxDB. And finally, it cascades into a beautiful visual Grafana dashboard. You literally go from raw CLI text to stunning, real-time visual trends.
And why go through the trouble to set up a visual dashboard? One word: correlation. Imagine you're staring at your Grafana screen. At exactly 10 a.m., you see a sharp line graph showing delay spiking from a healthy 5 milliseconds all the way up to a disastrous 200 milliseconds. Right below it, on the exact same timeline, interface utilization shoots up to 95%. The visual correlation is instant. You don't have to guess. You know with absolute certainty that the delay is being caused by link congestion. It rules out complex routing issues in seconds.
Okay, to wrap up our investigation today, let's summarize our key takeaways from this explainer, from ping to true observability.
RPM is a fundamental shift in how we approach network health. It upgrades you from those single, passive pings to active, continuous measurement. It exposes the hidden gremlins like jitter and micro-packet loss that completely ruin user experience. Plus, by allowing segment-by-segment monitoring, it turns you from a guesser into a total sniper when finding faults. And when you integrate it with telemetry and visual dashboards, it really forms the backbone of a proactive, highly observable network.
So as you head back to the trenches tomorrow to face those inevitable user complaints, I want to leave you with this final thought. Ask yourself, are you still just pinging your network and hoping for the best, or are you truly observing it? Thanks for joining me on this explainer, and I'll catch you all next time.